Say warm good evening to all of you. I can see only very few faces here. This is the last session and I know you are all eager to go back. So I am working in Model Engineering College. I have studied in Model Engineering College. So for the last 35 years I have been in biomedical engineering. So when Model Engineering College started, we didn't know what biomedical engineering is. But in our class, one banner was there, you go east, you go west, biomedical engineering is the best. So we all blindly believed that slogan, and we thought that once we complete biomedical engineering, we will be much demanded in the field and we will be getting very high salary, very good jobs. We all dreamed like that. But even after 30 years also, 33 years also, the scenario didn't change much. But slowly it has been picking up. So when I did my master's in College of Engineering, Guindy, that was actually part of electronics department. So our course was medical electronics. And that time, artificial neural networks were introduced. And when I came back after completing my studies, I thought this neural networks is picking up. So we included that in our syllabus. So if you see the syllabus of biomedical engineering, you can see that it is actually a right blend of clinical applications, biology, electronics, as well as computer subjects. So biomedical engineering is actually a very specialized field, and people do argue right now also whether you need a program in biomedical engineering at the undergraduate level, because it's a very specialized one. But as students, actually you should be very honored, because when you are studying something very special, actually you can go directly into the field. So if you study electronics engineering, you need to have a specialization for working in a specialized area. But in biomedical engineering, that is not the case. Then if you have, so when we see a class of students comprising of 60 or 70 students, the 70 students, 70 individuals are different, and their interests are different. So in curriculum, actually you have plenty of options for them to chase their dreams. Like if you are interested in hardware, you can go for hardware specialists concentrating of electronic subjects. Like you can have microcontroller based projects, then you can implement those things, because right now it's not very they are very affordable. The price is not very high. You can get acquisition boards. So when we were teaching in the initial years, we were building every acquisition board by our own. So the students were having that much knowledge. But the building an amplifier was a tough job. Building an ECG amplifier was a main project. Then displaying it in a computer monitor or a device, it was a very big challenge. Right now it is very easy. You just plug in the board, you can see the ECG moving on your screen. So right now technology has advanced so much, and you can see in biomedical engineering, in any emerging technology can be applied. So it is having applications also. Then actually I was interested in software side also, but when I joined, actually I didn't get for computer science for undergraduate stream. But finally I ended up in doing my research in simulation job, because that is also a very promising field. Like if you are interested in doing computer programs or working with computers, lot of opportunities are there. So I worked in computational neuroscience lab in IIT Madras. So there actually they were using computational models for studying functionality of brain. So how brain is functioning in different types of neurological disorders, what were the pathways that actually affect the motor dysfunctions. So when you analyze that, actually you are probing deep into the brain and see how it works. And my work was actually computational cardiology. By using these neuronal models, I analyzed how heart is functioning. So you know that heart is having SA node, AV node, that kind of networks. So when heart is functioning, we are getting the electrocardiogram. So electrocardiogram is actually the electrical potential variations on the skin surface. So this is originated inside the heart. That is, when SA node is producing an impulse, it is propagating throughout the heart, and the pattern by which it propagates is actually giving the shape. So when you understand it deeper, you understand how arrhythmias are being formed, what all treatments can be given to arrhythmias, how this, so every cell you can see what the potential changes are happening. So by clinical experiments or by doing studies, actually you cannot probe every cell and see how it's functioning. So a right blend of programming skill, hardware concepts, and right understanding of biology can make you a very good biomedical engineer. So keep updating your skills, and the role of teacher has actually changed. So when we started teaching, actually we were teaching what is there in the book and making students to understand the fundamental concepts. So right now, maybe because of the change in the social networks or how students are getting influence is totally different. So they are actually not much being keen on understanding the concepts. They will just mug up what is there in the textbook or in the notes, and they'll write the exam. So right now the teacher role is totally different. So we are not content delivers, because right now content is available in different forms. So they can actually watch some videos, or they can get some short PDF notes, they can get the content. But how this is applied to the field is different. So teachers should be changed from the role of teacher to a mentor or facilitator, and students should be working on something. So right from your first year, you take up some project, do it, understand it, make the concept, then in second year you improve on it. So that is how you develop the skill and you make a very good engineer. So this engineering, biomedical engineering is not about skilling, but it's a mindset. You apply whatever you know into the field and you can be a good engineer. I think I can stop now, it's very late. Thank you for inviting me.